All right, so today we're talking about organizing real and complex numbers, and like I have said, and like I said before, this is a mixture of old stuff and old stuff. In other words, a mixture of things we've learned before. Okay? All right, so notice the Venn diagrams that we have here. It says label the Venn diagram below with the following number sets: real, irrational, rational, integer, natural, whole, complex, and pure imaginary. So let's start with the real. The real is the box within the box. So this is our real. Okay? And as I use one of these things, I'm going to mark them out. So this is real. Now remember the symbol for real. It was double bar R. Okay? Now, within the real number system, we've got the rational numbers and the irrational numbers. Now the rational, I'm going to write this up here. The rational is the big circle, and the symbol for rational was a Q. Why they use a Q, I don't know. I'm sure it has something to do with Latin. All right, now, what are the rational numbers? Rational numbers are any number that can be written as a fraction. So I'm going to write fractions, percents, decimals, decimals that repeat and decimals that terminate. Okay? So those are just some examples of rational. In general, any number that can be written as a fraction. Okay, within the rational number system, we have the integers. Okay, and what was the symbol for integers? Does anybody remember?
Z?
Yes, good, Paige. Z. Okay, and underneath the integers, or within the integers, we have the whole. What was the symbol we used for whole?
W?
Yep. And then within the whole numbers, what do we have?
Natural?
Yep. Let me pause this. Whoops. Pause this real quick. Alright, back on video. Okay, so the natural number symbol was N. Okay, now the natural numbers are the numbers that we say when we count, like 1, 2, 3, 4, 5, 6, so forth. Whole numbers are the natural numbers, including 0. The integers are all the whole numbers and their opposites, so the negatives. All right, inside the reals, we also have the irrational. The symbol that we use for irrational,
It's I.
you can either use a capital I or a P. I don't know why they use P. Again, it probably has something to do with Latin. Capital I or P or capital I will be fine. All right, now, outside of the real, we have the imaginary. So the imaginary consists of pure imaginary, which we know involves an I, lowercase I. There may be a special symbol for pure imaginary, but we're just going to say PI. How about that for right now? All right, now, the pure imaginary system, pure imaginary numbers, along with the real numbers, make up the complex numbers. And the symbol for complex is a C with a little line here, like an old English C. Okay? So there we have our symbols and our different sets of these numbers. Now, what we're going to do is we're going to simplify and classify these numbers. Now, to do this, we've got to be able to simplify. So we've got square root of negative 64. What is that? 8i. Okay, so 8i would fit where in these numbers? Pure imaginary. What else?
Complex.
Complex, good. Okay, number 2. 10 times negative 2 is negative 20. I squared. All right, what happens with the I squared?
It goes away and the 20 becomes positive.
Okay, so 20. And what type of number is this?
Whole,
Natural,
natural,
whole,
integer.
yep, rational, real, and guess what else? If it's real, is the real contained in the complex? Yes. You say, wait a second, how can a real number be a complex number also? And this is how. 4 plus 0i. That looks complex to me. Is 0 a number? Yeah.
The whole.
0's a number. So I've got a real part, I've got an imaginary part. But the only thing is, what happens when I do 0 times I? It's just 0. It simplifies, but it's still complex. Okay? All real numbers are contained within the complex number system. All right, next. Square root of 1/9. Well, yeah, you can. What's square root of 1? What's square root of 9? 3, so 1/3. What type of number is this? It's rational. And what else? Real. And what else? Complex. Okay? Alright, number 4. We need to change our signs. So plus, minus, plus. 15 minus 9 is 6. Negative 8i plus 3i is negative 5i. So what type of number is this? Complex, and that's it. It's not just real. It's not just imaginary. It's complex. Alright, number 5. We have to multiply by the FOIL method. So when we do this, we get 36 plus 20i minus 9i minus 5i squared. What can we do? Get rid of I squared. Change the sign. Combine like terms. So what do you get?
Plus 11i.
Very good. What type of number is this? Okay. Now, when it comes time for the quiz, if I give you some problems like this, I'm also going to give you the chart. Okay? Alright, number 6. Now, what do we do when we see I to an exponent, like 41?
That's I, Coach.
Divide it. Good.
That's I.
Divide by 4. So 41 divided by 4 is going to be 10.25. And that 0.25 tells you what?
1.
It's going to be a remainder of 1.
So it's just I.
So it equals I. Very good. Alright, number 7. Okay, we need to cube the negative 2. That's saying negative 2 times negative 2 times negative 2. Oh, I'm sorry. What is it?
Complex and imaginary.
Pure imaginary and complex. Very good. Alright, number 7. Negative 2 cubed is negative 8, and then the I cubed times root 7 squared is 7, I squared. So we multiply negative 8 times 7, negative 56. 8 cubed times I cubed times I squared is I to the 5th. So what is I to the 5th?
I just did it. I.
It's I. Very good. I to the 5th is I. Why? Because there's a remainder 1, right? It repeats. So it's going to be negative 56I, which is complex and pure imaginary. Alright, number 8. What do we have here? What do you call these numbers?
Starts with a C.
C-O-N, conjugate. Conjugate. So these are conjugates. Now, whenever we multiply conjugates, we get a real answer. So I know automatically it's going to be real. Now, it may be some other things too, so let's see. 9 minus 25I squared. What do we do? Change the sign, cancel the I squared. 34. So, 34, is that natural? Is it whole? Is it integer? Is it rational? Yes. Is it real? Yes. Is it complex? Yes. Yes. There you go. Okay, I to the 16th.
Is it imaginary? Yes.
When I divide 16 by 4, do I get a remainder?
No.
No. So what is it?
I of 4 is 1.
1. When there's no remainder, that matches up I to the 4th, which is 1. So, it's a 1. So what is that? Natural. Start at the bottom. Natural, whole, integer, rational, real, complex. If it's natural, it's everything above it. If it's whole, it's everything above it. If it's an integer, it's everything above it. If it's a rational, it's everything above it. If it's complex, it's only complex, because there's nothing above it. Okay? Square root of 150. Alright, what is the largest perfect square factor of 150? You're kind of on the right track. 25. 25 times 6. Root of 25 is? 5. So 5 root 6. Okay, what type of number is this?
Is it real?
It is real for sure. What else is it?
Is it rational?
It is not rational.
Irrational?
Irrational. Oh, so it is irrational, and you can use I or P. It is real, and it is complex. All right, turn the page. No, right now. All right, so the next topic has to do with another part. I told you this was old with old, right? So here's another old thing that we've already done. That is properties of numbers. Now, we talked about properties of real numbers. Now we're talking about properties of imaginary numbers or complex numbers. And the properties are going to work exactly the same way. So follow along with me. The properties of real numbers, commutative, associative, identity, inverse, and distributive can also be applied to complex numbers. So we're going to write an example of each of these properties. And you're going to be asked to do this for homework, so you need to pay close attention here. The commutative property of addition. What does it mean to use the commutative property? What am I changing? Not the grouping, that's associative. Flipping it around, that would be changing the what? Starts with an O. Order. So, we are changing order. So, here's an example. We could do 4 plus 3i equals 3i plus 4. That is A-OK. They mean the same thing. Now, we're going to generally write these in standard form with the 4 first, but it's not wrong if you don't. Alright, associative property of multiplication. This is where we change the grouping. So change grouping. Alright, so associative property tells us to change where the parentheses are. And this is going to look kind of weird, but don't get too confused by it. Alright, 4 times bracket 5 times 3 minus 2i. And you say, well, that's confusing. No, it's not. All it is just multiply, multiply. It's just a product. Do I need to put the brackets there, really? No, I did that. I did that for a point of emphasis. Okay? Alright, so here's the thing. I can regroup this, but leave the same order. I can say 4 times 5 in parentheses, or brackets, one, doesn't matter, times 3 minus 2i, and I didn't change the value of anything. I just changed the grouping. I didn't change the value, I just changed the grouping. Alright, next one is distributive property, very basic. 4 times 3 plus 2i would be 12 plus 8i. That's so easy. or we just distribute. You're not changing anything, you just distribute. Alright? Identity property. What is the identity property of multiplication? What is the multiplicative identity? What number is it? 1. Anytime I multiply by 1, I get what I started with. So it is identical. Okay, so what is an example? 3i times 1 equals 3i. That's simple. Alright, so what if it was addition? What would I do for addition?
Anything plus 0.
Plus 0, exactly.
So 3i plus 0.
3i plus 0 would be 3i, so that's the 0 is the additive identity. Alright, what about inverse property of addition? What does it mean to be inverses?
It has to equal 0?
For addition, that's to equal 0. So if I did 4 plus 5i, let me do negative 4 plus 5i. Alright, what would I have to add in order to get 0?
0.
No. Positive 4 minus 5i. Change the signs, just the opposites. When I add opposites, I get 0. What if this was multiplicative? Inverse. You'd have to get 1. So let's say I did 1/4 times the number equals 1. What would that number be?
1.
1/4 times the number.
Oh, wait, it'll be the same thing.
1/4 times what equals 1? 4/1. Reciprocals. So, if I had this, if this was multiplication, if I had 1 over, let me do it like this, if I had 8i times what equals 1, what would go in the denominator right here? 8 what? 8i. Now, is it legal for me to leave an 8i in the denominator? No, so technically, I would have to make this, I would have to get rid of this imaginary number by using the conjugate and doing all that. But for right now, I'm just going to leave it like this. Alright, for these questions, we're just simply going to just tell what property is being used. So what property is this?
Multiplication.
Well, you are multiplying, but which one of these is multiplication? Distributive. I'm distributing to 2i. Let's go through these quickly. Alright, number 17, what am I doing?
Inverse.
Yes, inverse of what? Multiplication inverse, or multiplicative inverse. Alright, number 18, what am I doing? Associative, good.
Now give us Tom, McKay.
Associative of what?
Addition.
Addition. Alright, Tyler. What is 19?
I'm still running right now.
It is what? I'm adding 0. Additive, it is identity of addition. So, additive identity. Alright, number 20. What do we have? Yes. Who said that? Who's me? Jalen, good job. Commutative of multiplication. Alright, 21. What do we have? Inverse, good. Additive, inverse. Because anytime we add numbers to get 0, we're adding inverses.
But then how is 19 addictive?
Because here we added 0. We didn't add to get 0. We actually added 0. So 0 is the additive identity. So anytime we add numbers to end up with 0, it's additive inverse because we're adding inverses. Anytime we add 0, that is your additive identity. Alright? Name the additive and multiplicative identity of 6i. Additive and multiplicative identity of 6i. So, if I'm dealing with identity, what would I need to add to 6i to get 6i? 0. So, 6i plus 0 equals 6i. Alright, what would the multiplicative identity be? 6i times what? 1 equals 6i. There you go. Alright, name the additive and multiplicative inverse of negative 8 minus 3i. So the additive inverse, negative 8 minus 3i plus what equals 0? Excellent. Excellent. Good job. Just the opposite numbers, add the opposites and you get 0. Alright, what about multiplicative? Negative 8 minus 3i times what fraction equals 1? Alright, you said a lot of things. I think you're on the right track. Just do the reciprocal of this. So just 1 over negative 8 minus 3i. Okay? Now, is this the proper form? No, not technically, but we're going to leave it like this for right now. Alright, the last 5 problems here are just some true-false questions. If it's false, we want to provide a counterexample. So here we go. The set of complex numbers is closed under addition. To be closed means that if I add complex numbers, I'm going to end up with a complex number. Is that true or false?
True.
That is true. Alright. Next, the set of complex numbers is closed under division. In other words, if I divide complex numbers, am I always going to end up with a complex number? Yes.
True.
True. 26. All complex numbers are pure imaginary. That's false for sure. Give me an example of one that's not pure imaginary. 1. Very good. Excellent. Excellent. Example 1. Let me just do that. Alright. A number cannot be both irrational and complex. False. It can be. Give me an example. Is 1 irrational? No. Pi plus what?
0.
3i would be 0i. Okay? So a number can be both irrational and complex. Alright? The product of a real number and a complex number is a real number. False. It might be sometimes.
It's a real and complex.
But the product of a real number such as 4 times 3 minus 2i is going to end up as a complex number, not as a real number. Okay? Alright, so good job. Now, your homework, okay, your homework is going to be on homework 5, numbers 17 through 21, I think. 22? 17 through 22. Homework 5, 17 through 22. You can also go to homework 4, 1 through 19, or 17, one or the other, odds, and those will give you some good practice for the quiz. Okay, so all of that together will be good practice for the quiz. So again, homework 4, 1 through 17 or 19, odd, not sure what it is, and then 17 through 21 or 22, whatever it is, 22 on homework 5. All right.